And in this video I'm going to take you through the steps to have deep learning models, specifically with YOLOv8 v9, run on Raspberry Pi 5, Pi 4, Pi 3. It should work for Jetson Nano. I will do a separate video on that for you. So in this one, we are going to use this library, this new library, which is Edge TPU Silver, which is on Pyenv already. So it's going to help us use the power of Coral Edge TPU, the USB accelerator, and then some Ultralytics models. So it will help us run the YOLOv8 v9 models as well. So all these two encompasses into the Edge TPU Silver package that we are going to use. The Python package, there is the detection, segmentation, and classification capability, all fused into one package, and it's highly dependent on the Ultralytics package, and then the Coral. So, and its installation seamlessly happening in one single pip installation. We look at the hardware requirement that we want to have, which is the Coral USB accelerator. So you need to have that hardware. So you plug it into your Raspberry Pi, whichever you have, and then there's going to be the installation that you need. We do this first. So we do this before the installation of this Pyenv package. So you need to go and then you need to have a virtual environment set up with the specific Python version that it takes. So it takes Python versions less than 10, and then you can see it has it here as well. Requires Python 3.6 and less than 3.10. So once you have that, and then on your Raspberry Pi by default, and now if you install, you probably will have Python 3.11 installed, and you would want to have several Python versions installed on your Raspberry Pi, and there is a link even to that page as well. So let's go to the GitHub page, and then we see what is on there. Same documentation like it's on the Pyenv page, and then the first one tells us about the hardware requirement I did mention about, and then we do this before installing the package. So with this demo, we are going to do a test run on Raspberry Pi 4, and then we will also do a quick demo on Raspberry Pi 5 as well. It works just the same way, but the compute in Pi 5 is very fast relative to the Pi 4. So in here, so it says do this, and it says, for example, Raspberry Pi, you can install specific Python versions using the Pyenv here. So what I will do first is I'm going to quickly go into how to get your Raspberry Pi OS using the Pi OS runner. So I have this Raspberry Pi imager, and I want to choose my device. Like I said, so if you have Pi 4, you can select it. Pi 5, you can pick it up. There's 3 as well. So I'm using my Pi 4, and you need to be on a 64-bit device as well. So I have Pi 4, that is what I want to run my processor on. And like I said, we will do a test on Pi 4 and then Pi 5. And it's still the same process for installation. Now, operating system, I'm going to use the bookworm because that works way perfect. I haven't done a test on the dose package and all, so I'm using the recommended bookworm. And then if you have your USB, I have a 64 gig USB plugged into my system, so I select that, and it asks you to go next. So I already have some settings in my system. I have my local host, I've changed it to Swift, username, you can change it to whatever, and then password, you can change it to whatever you want if you want default. But if you want to set up everything as the installation is going, you could do that as well, but This one helps me have everything set up on the go for me. So once the Pi is boot up, you already have Wi-Fi connected and everything in the system. So in here, it takes your SSID for the Wi-Fi, the name, and then the password. And yeah, so for now I just leave everything as default. So I have a username for my Pi, localhost, so Silva, and then I can go on. It could be any name you want. So I save this, and then I do, would you like to apply this? Yes, I want to apply that. Ask to erase the drive. Yes, I want to erase the drive. So this is going to take quite some time. Couple of minutes. My writing to SD card is completed, so I hit continue. Then I can unplug my SD card from my system and then connect it into my Raspberry Pi. And you connect your monitor, and then if you have wireless keyboard or wired one, you plugged it in, and then you boot up the Raspberry Pi system. So hooking up my Raspberry Pi to my monitor and all, I had to do a couple of things to have my VNC into my computer so you can see what I'm doing. So this is you on your screen and nothing has been done. So you booted up freshly on a new Raspberry Pi with a fresh OS. And then I just used my Chromium. I went to the GitHub. So we'll have the link in the description. So we are on the GitHub page here. So on this GitHub page, right here, we looked at this before. So we pass our hardware requirements. We want to do this before installing the PyP package. So this is only compatible with Python versions that and all. So you would need to check for your environment. And if you have that Python environment set up, you have an environment where you run the code, that's fine. But it's recommended you follow these procedures so you have the best results. So if I check my Python here, you see I have Python 3.11 and it's not compatible. So I want to step down to 3.9 or somewhat. So here it says if you want to have specific Python versions in your environment, there's some steps here you could follow. So it leads you to another page. So instructions to install Python versions on your Raspberry Pi. So here we need to be sure our Raspberry Pi is up to date. So first we copy this code, we come to our terminal, and all that we're going to do, most of it is just paste this code. Some might take a couple of times to load. So that sudo get update is done and we want to do sudo get upgrade. That might take a couple of times depending on how fast your internet and all is. Okay, so we have our Raspberry Pi system updated for the APT, which is very useful. You need to do that, else it won't behave just the same way you want it to have with the Pyenv to install the specific Python environment for you. So now step one is we want to install the Pyenv. We run this cal code and then we paste in here, hit enter. It will download everything automatically for you. So this is, if you have your Python environment set up, that's fine. And then step two you would need to follow these ones. So step 2, I copied that as well. You need to copy everything straight away and it will do the work for you. You just hit enter, and yeah, so you are just putting these to the path so we can globally access the Pyenv, and we just refresh the shell. And then step 3 here as well, we're going to install all of the dependencies that the Pyenv is going to need. Okay, so that is done installing. Now we have all the dependencies for Pyenv also installed as well. Now if you hit Pyenv and if everything went well, you should see instructions on how to get Pyenv running, and it shows you the version. When I did run Pyenv in my terminal, Pyenv, it shows you the version you have and all of this. So if you didn't see this, make sure you go back and follow the steps just the same way we were doing it. So if you did, then we can go ahead and install a specific Python version you want to use. So as step 4, now because you have Pyenv, you can now install any Python version you want on your Raspberry Pi system. So down here with Pyenv, I want this specific version just as it comes with it, and then I hit enter. This step does take some time, and it also depends on your internet speed. We have it installed. We have our Python version installed. Now the last step in this file, we want to set this Python version either as local or global. You choose which one. So for local, if you're in a specific folder and you want to make this Python version available for just that folder or shell, you could do that. I love to go with global, so I could create a separate virtual environment with that Python version that is global. So if I want to delete my virtual environment, I can do it. So I'm going with the first one. I want to have this as global. So it's just Pyenv global, then the version that you just installed. And then, yep, we have it. So if we check our Python version again, and then we hit version, it should be the Python version that we just installed. So if you are not on this same line, please go back and follow so you have this. Now, everything is installed. We are done with this. So we can go back to here, installing our Python package so we can have our Raspberry Pi running at its high speed. Yep, so with the nesting, like I recommended, it's good to be in a Python environment. So you can copy this code here, and then you just paste it. So Python 3, you create a virtual environment within the folder you want to have this done, and then you source that virtual environment. So ls, I want to create a folder in here. You can do it manually in your folder directory, and then you can open it here as well. So I want to call this silver. For this, then I want to create a virtual environment for this folder and activate it. So in the future, you can just create different folders and then work with it differently. I paste the code I copied from the documentary. I just hit enter, and you wait for your virtual environment to be created and activated for you as well. So while we watch that done, the next step after that is to pip install. So we have our virtual environment created for our folder and also activated. So if you don't see this VNV next to your shell, then you have to go back and do it right. So for the installation, it's just pip edge TPU silver, and that is the moment we've all been waiting for. So pip edge TPU silver, you hit it, and it goes to source all YOLOv8 dependencies. It uses OpenCV, Ultralytics, TensorFlow Lite, and then the TensorFlow Lite runtime, the edge TPU runtime as well. So you don't have to, because if you go on the Coral website, most of the steps that they show are a bit like redundant. I was getting a lot of errors, but this gives me that single flow. So we have our edge TPU package all done, installed. So that will be the last step, is based on your OS or the system you're using, you need to run a setup command. So it would automatically install all the runtime requirement that you would have done manually separately to have your installation done. So we go to the documentation. There is run setup. So for your system compatibility, based on the system you are using, you run which one. I think there is still some work being done for Windows, Mac OS. So but right now for Linux based system like Pi4, Pi3, Jetson, that is compatible. So it's Pi4, so you just copy that command, and then beneath here there is the use case. So for an example, if you are on Raspberry Pi 5, run this after everything is done installing. So if you want to run this as setup, this will automatically configure that the Edge TPU Accelerator would work, and this is with its standard speed. There is the second one where it takes this argument as dash speed max, and it would run the Edge TPU at its maximum speed, and that will make it relatively faster than the first one without the speed argument, the max argument. So based on your use case, but I don't see the speed to be that much relatively, so maybe it might be different for your system, but the max goes a higher speed than this one, but it heats up. It makes your USB accelerator heats up a bit, but so you need to watch out for that. So it gives you all the arguments that the Silver TPU installs. So there is Silver TPU Linux setup, and then Silver TPU system. So even if you don't want to go straight with the Linux.setup, if you do like system here and you hit run, it checks your system and tells you which setup command that you could run to get you set up for your particular system. But you could just go out way straightforward. You see, it did return. It tells me that you're on a Linux Debian system, and I can run that to get me set up. So I'm just going with the base, and you could do the max. We will try the max separately as well and see how it works. So if I run this, it's going to get all the installation that you would have gone manually through the Coral sites done for you automatically, and gives you all the compatible TF Lite runtime that would work with the Accelerator as well. And you might get a couple of warnings, but it would work automatically after that. Yep, and this warning you're seeing down here is just your pip, so you could just run pip install upgrade if you don't want to see this warning, but I'm good with that. So it tells you the setup installation for Linux Debian is completed. And if you look here, it did install TF Lite runtime, Pi Coral, for you as well. And the Coral version, TF Lite version, that is compatible for this. So we are all done in terms of all that we need for installation, and you can run any of the code that is on the page, any of the sample code that is on the page. And the beautiful thing is they provide some sample models based on some of the Ultralytics packages as well. So for YOLOv8, and if you want to have the Edge TPU compatible version, you can just hit the download link and it shows all the object classes that are within that class if you would want to see. So it tells you all that this model can detect: a person, a bicycle, a car, motorcycle. So all of the objects that is in Coral 128, you could have it once you download this specific model. So we are going to try with the 194 size. And note, when you are exporting your own custom model, you need to read some of the notice here that whatever image size you use to export it, you need to define that for the image size argument for it to work for you seamlessly. We are going to try the 129 for object detection and segmentation. So here I hit download for 129 and that was for my object detection. And then it's done downloading. I can download for my segmentation as well. And yeah, that did download it. And I'm going to download one more. So you see that as the image size for export 10 increases, it tends to bring down the speed a bit, but relatively so. You need to know your use case and how much of a tolerance in terms of processing speed you want, and the YOLO model you tend to export. If you are using V8N, it's lightweight. If you go in for the large models or the M models, they are going to be relatively slower. So choose your models just the same way you would want to use them. If I come to my downloads folder, I should see these downloaded. And I did mention we are going to download the 2.4T image size. And these are all converted to the TF Lite models already. So you don't need to convert them. So you can just use them straight away with all the example that comes here. But if you have your custom model, you would need to convert it. I see there is a V9C, so YOLOv9C, and that is a very huge model. So, and there is a note that states it's relatively very slower. So you should expect probably there's a V8, V9, and it would run comparably faster. And it's the beauty how you can straight away work with V8N, straight away work with V8 and V9 with the same package straight away. And all thanks to the base Ultralytics package that this depends on as well. Yep, so we go back to our downloads folder. We have all our packages in here, and what I would want us to do is we are working with our silver folder. So I want to move them into my silver folder. I come back into my terminal. I do pip, I do ls. It's going to show all the packages that I have downloaded right here. Yep. And then what I'm going to do is also transfer like a video file through a USB. I now have my video transferred through my USB drive. I have this video of a man working. Yep, and this is what we're going to use. The video is already it has some slow-mo effect, so it's not the system that is running slow. It's a slow-mo video. And yep. And if we come back to our terminal, I can close this, and all you need is your video and your TensorFlow Lite model to perform your detection straight away. So if I come in here and I do my ls again, you should see there is the video file included. There is 2 test runs for this Pi4. I'm going to demo how we are going to do our test run through the CLI. When we switch to the Pi5, we will do a test run where we have our Python code in a Python file and then we run it as well, same way. So now here you could just import in your Python script, import Edge TPU silver and then import process detection. And process detection is going to take some arguments, the model path right there, as well as the input path for the video you want to use, and you define the image size based on the image you use to export your YOLO model as well. And then you can run this. It's a generator out function, so you need to source the output right. And then now if we go down here, there is a table that tells you all the input it takes as well as the CLI command. So we are interested in this. I copied the CLI because I want to run this first through our command line interface. And then I paste the code here. So to run through the command line, you specify silver TPU, yes, and then -p, or you can spell in full -process to specify the process you want to have. Seg is for segmentation, that is for detection. So I want to do for detection, and then the model you want to use. Then you define the model name. So in here is my 19. Let me refer back to the folder. So yep, I want to first try with the 192 model. 192 YOLOv8 and that's all. So this is the object detection model, and the segmentation models do have seg with their names. Yeah. So, and then my video path tab to have it, and then -z or image size is 192. You could set the detection threshold right there. You could set verbose, which is already naturally true. So my detection threshold, let me set it to say 5. You could remove it if you want the default threshold value. And you can run this now. And before you run this, you need to make sure your Coral Edge TPU accelerator is now connected to your Raspberry Pi. And you see there is the blue and then there is a gray-like ports. The blue ones are the 3.0 ports. They gives you the fastest speed compared to the 2.0 port. So you want to use the 3.0 ports for faster speed. Now if I hit run, we should expect our processor to start object detection with our video for us. And then model is load to the system, and now yeah, we can see how it's saying 20 FPS on the Pi4. We would test on Pi5 and you see how it would boost up dramatically. So it's very fast on the Pi5, but I just want you to see how it works on the Pi4. You got a couple of warnings, but still I think those are handled very well. So you see we had FPS of 24 relatively on this system as well. So now you could show, so you see show to true, and you run this. This is going to show you the frame for the output. It's like how you were seeing the detection. Yep, and like that, as the frame is being shown here, you see the frame rate does drop. Well, like I said, it's a slow-mo video, and 13 frames, 14 frames per second on a Pi 5 is already decent. On a Pi 4, sorry, is already decent on its own. So yeah, you had few steps to get us to this point. Processing is being done accurately. Now let's go on to the main boss, which is the Pi 5. So we run a test on the Pi 5. You follow the same installation test I did for Pi 4, and we do same on the Pi 5, and I'm showing you how the Pi 5 tool is way faster than the Pi 4. So this is a good comparison for you as well. I'm here on the Raspberry Pi 5 UI system, and I did go through all the same steps that I did with the Pi 4, but then I have installed my Pyenv, created a virtual environment in a new folder I called demo for my Pi 5. So if I do my Python in that version, I know it is, yep, still same Python version that I have here. And I did install my Edge TPU silver and everything. So if I go in here, you can see that all the entry points that comes from the Edge TPU silver are still available. Yep, but I did install this. But how about if we try the maximum speed for the accelerator, so we tend to like get the highest speed on our Pi, even though we are still on our Pi 5. So we do that speed. When I did observe is for my system, everything tends to be like the speed was, I think the difference was about 5 frames per second or so. Yeah, which you would need that 5 frames per second for whatever application you want for the max speed. So I just specified this parameter speed as max, and then I hit enter. And notice, because I have the standard one installed with the standard speed, and there will be some warning instructions for you, and you grant as yes, and then you go on with the installation. So it tells you that setup installation for Linux Debian is completed. And yeah, if I do pip, what do I do? Pip list all the time. So list, you should see in here I have 3, but this time around I do have also the text.py file in my folder. So let's go into our folder, and down here in demos folder, the same man working detect.py, and then these libraries, these models, TF-Lite models that we are going to use. So if you had your accelerator plugged into your Pi, you need to unplug and plug it during the installation. You need to unplug and plug it back in, so everything works like you have it. And for my new Raspberry Pi 5, one thing I did notice is for the 3.0 port, it might be with the specific one I have with me, I need to, like, the port was loose and it wasn't making good contact with the USB, so sometimes I had to adjust it to get it running right. But yeah, so if you don't have any loose connection with your accelerator, then that's cool for you, but everything is working. So let's go into our terminal, and then just like we did before in our V4 code, Pi 4 code, we want to use the 1992 model, just like we have here. So I want to have a processor of death. I'm running through the command line, then I go into a code file, and then we see everything in there. So I have Silver Edge TPU model. I define my model that I want to use, the video. For now, I don't want to show anything, but I want to specify my image size as well. And then if I hit run for this one here, it should run with the detection. Okay, so this was one of the errors that I got when there was like a loose contact. Still same, I tweaked it a bit, and then again for my Pi 5. Yep, then I just had to adjust the cord in a way, and you can see we hit 61 frames per second on the Pi 5, which is very cool. So 61 frames per second on our Pi 5 without showing frame. Now on the same thing, we want to add this argument. We want to show, set it to true, and then we run. It's going to drop, but not as much as it did on the Pi 4. Yep, and we have our frame running, and you can see we have 27, 26, which is very decent to work on a real-time processing use case for object detection. So yep, that is for object detection. And then there is also a segmentation model that we are going to try. So with this, we do have the processor to seg. So based on the model you download, you use it, right? All right, and then there is a dash seg for the segmentation model. I think that is pretty much the difference. Let's not print the CV window, and let's see how much of a frame rate we get without showing it. Yep, and for segmentation, segmentation processing is a bit huge compared to object detection. You do see some frame rate of about 42, which is still decent with the processing speed for segmentation. Yep, and yeah, it did run to the end. Now we show and set it to true. And it does drop, but you see it gives us our segmented region with a frame rate of 20. And yeah, and you could define your threshold so some of the false detections go away, but this is really decent for segmentation on the Pi 5, and the frame rate that we are getting still around real-time processing speed. Yep. And just to be quick, here I go in here. There is a file that I have created with a det.py, which was also from the code base. So in here, I define my model that I want to perform the detection on and still pass my video, and I want to show, I set it to true. If I come to my terminal, you could just run, and I just want to run it through the same virtual environment that have my code. If you could source your virtual environment to Tony or whatever IDE you're using, then you should be able to run it perfectly without any issues. But I know that I have my detect.py also here as well. So I could do just Python 3 dash then detect.py. And it's going to perform the object detection like we were doing in a command line, but here you write your code, you choose what you do with whatever the output is going to be. But if I run this, it should still run just like we were doing through the command line without any issue. And yeah, here we have it with frames showing 27 frames per second. That is so cool. And if you would want to work with the output, let's say we want to see some of the outputs here. Let's first do one thing, set the verbose and then put it to false, so nothing is printed to the terminal. And then if we come in here, if you check the documentation, so if you look in the documentation, it shows you how to source the outputs. Let me quickly go into the documentation, TPU silver. Yep. And you see here, it shows you how to source the output. So there is objects, there is the FPS if you want that value to for whatever. This is where all the objects for object detection segmentation are stored out of the generator. So if, let's say, I copy this for loop, and then let's just bring it into our code. Yeah, so for the object and that I want to just print the length of anything that is being predicted, and then we want to see the whole thing, what is in there for each detection action as well for the object list, because there will be some items and you will see it will hold information about the bounding box, the name of the item as well. So I do if, and then I come in here, and then still Python 3 detects the .py, and then I hit enter. Yep, and there's a lot going on here, but it tells you process frame with one object detected, two based on what it was able to pick up in the frame, sometimes two, sometimes one. So a person, potted plants with a person sometimes. And then the whole array that shows you, okay, there is ID of 0.0, label is person, it's confident, and the bounding box if you want to use it for whatever application you want to. So one last thing is for all on Ultralytics, which is the power in YOLO right now, all the codes under, if you go under the predict with the Edge TPU silver installed, you can still run most of these scripts in there, and you just need to provide the Edge TPU model, which is the TensorFlow like model that you would export or you get to download from the Edge TPU silver repo that I showed you all. And yeah, that is how we get the power of Ultralytics and Coral USB powered with Edge TPU silver. Thank you all for watching and help support.